Hello, this is question 2 on your June 2022 Statistics AS paper. So you have a manufacturer of sweets knows that 8% of the bags of sugar delivered from supplier A can be dumped, and a random sample of 35 bags of sugar is taken from that supplier, and using a suitable model, find the probability that the number of bags are exactly 2 or more than 3. So you have a fixed probability. You have a success, which is the bag being dumped, and a failure that is not being dumped, and a fixed number of items that you are checking. So you can say that this is a binomial. So that's the first thing I recommend you to write, because you are going to get a mark with that, just writing that it's a binomial. So if x is the number of bags that are dumped, it's going to be distributed with a binomial. N is 35 and P is 0.08 or 8%. Yeah? And now we can find any probability. So the first one is probability of x being exactly 2. So what you do is just using the calculator, you search binomial PD, probability distribution, because we have the equal, and N is 35 and N is 35 and P is 0.08, and you get 0.24 304 and so on. You can get round to 3 or 4 decimal places with these probabilities, and then it should be fine. So something like this, 4 decimal places. The second probability is more than 3. We are going to use more than 3 binomial CD in the calculator, because it's cumulative. Now we have greater, but remember, in the calculator we don't have greater, we have smaller or equal. So we have to rewrite this question in a way that we have smaller or equal. So this is 1 minus probability of x being smaller or equal than 3, because we don't want to include the 3. And with binomial CD in this case, we do 1 minus the value that we did in the calculator. We get in the calculator with x3, n35, p 0.08, and this is 0.3060024 decimal places. Yeah, so this is the first part. And you're going to get 1 mark for this one and 2 marks for this one, because you have to do this change. And then supplier B claims that when it supplies bags of sugar, the proportion of bags are dumped are 8%, are less than 8%. Yeah. The manufacturer takes a random sample of 70 bags now from supplier B, and only 2 of them are dumped. Carry out a suitable test to assess the claim. So the significant level is 10%. And the first thing we are going to do always is to write the hypothesis. So we are going to test the probability. So we are going to test if the probability is still 0.08, so still 8% of the bags are dumped, or it says it's less than 8%. So in this case, it's going to be one tail test, and this is going to be smaller than 0.08. That's what we are going to check with 10% significant level. And now is 70. Be careful, it's not 35 anymore. And yeah, 2 of them are dumped. So our observed value in the population is going to be 2. So remember, for this hypothesis test, you can do in 2 ways. One is shorter than the other, but the other one is easier to understand, I think. So I'm going to do both to remind you. We are going to check what is the probability of x being smaller or equal than the observed value, which is 2. And I'm going to see if this is smaller than the significant level, which is 0.1. Yeah, I'm going to check that. So if we go to the calculator with be careful, because n is 70, and in the calculator it's likely that you have 35 from the previous question. So n is 30, x is 2, is binomial CD again. This probability is 0.07397, which is smaller than the significant level. That means that is relevant, so you can say that you can reject 80. Yeah. Every time that is smaller than the significant level, the probability of getting this value observed in the population, when it's smaller than the significant level, we have to reject H0. So there is enough evidence to say that the probability is smaller than 0.08. Yeah. Because this is smaller than the significant level. Every time you reject H0, you have to accept H1. Yeah, so there is enough evidence to support the claim, or something like this, the claim. If you are doing international A levels, this line will give you another mark. So you have to write the conclusion. If you're doing the UK exams, it's soon enough if you write that you reject H0 and you accept H1, but you always have to write a conclusion. Yeah, you do a hypothesis testing to decide something. So you have to write always your hypothesis, you have to do the test, and then you have to write a conclusion at the end. Yeah. The other way of doing it is finding the critical region, and it's really up to you if they don't ask you a particular way, but sometimes they ask you to find the critical region and then do the test. So in that case, you have to do the second method and anyway, yeah. So for the second way of doing it, we are going to find the critical region. So I'm looking for probability of X being smaller than a critical value. I'm going to call it A. We are talking about one tail test. So I'm going to work with smaller or equal than A, and this must be smaller than 0.1. You have tables in your formula booklet, but they are up to N50 and we have N70. So we have to do with the calculator just trial and error. You have to go to the calculator, put values of A with N70 and P 0.08 until you find the first one that is smaller than 0.1. So the first one is when A is 2. And in that case, probability of X being smaller or equal than 2 is 0.0739. Yeah? So my critical region is going to be X smaller or equal than 2, which means that if my observed value is 2 or smaller, I'm going to reject. And it's precisely 2, yeah? So the observed value is 2, it says here, yeah? So I have to reject because 2 is in the critical region. It's in critical region, so I have to reject H0 and accept H1. Obviously, you're going to get the same answer using this method of the critical region or this method, yeah? It's so, as I say, it's up to you which one you decide. If they ask you the actual level of significance or actual significant level, that means they are asking you about this value here, yeah, the 0.073 in this case. Not because it's a critical region, but because it's the probability of getting X smaller than 2, yeah. And that's all with this exam question.